Welcome everyone. Today, we are going to work with authentication and authorization using JSON Web Tokens in .NET. In this full course, we'll build everything step by step, starting with user registration, then user login, adding roles and role-based authorization, and finally implementing refresh tokens to make our authentication system production ready. This means you'll learn not just how JWT works, but how to use it correctly in a real-world .NET application. You'll find the full source code available for download using the link below, so you can follow along or review everything at your own pace. And if you enjoy .NET tutorials like this one, don't forget to subscribe to the channel and enable notifications so you don't miss future videos. Now, let's get started by creating a new project in Visual Studio. Now let's create our project. Open Visual Studio and click on Create a New Project. From the project templates, choose ASP.NET Core Web API, then click Next. For the project name, we'll call it JWT Authentication and choose a location where you want to save it. Then click Next again. Here, make sure the target framework is .NET 10, since this course is built using the latest version of .NET. Enable OpenAPI support to easily test our API endpoints during development. Also, make sure Use Controllers is selected, since we'll be working with controller-based APIs. Once everything is set, click Create and Visual Studio will generate the project for us. In the next step, we'll take a quick look at the project structure and start preparing it for JWT authentication. Now that the project is created, let's take a quick look at the structure. Inside the project, we have a controllers folder, and by default, Visual Studio generates a sample controller for us. Since we won't be using this example code, we can safely delete this controller. We also have the program file. This is the main entry point of our application, and we'll come back to it later to configure authentication, authorization, and JWT. For now, we'll just keep it as it is. You'll also notice a model class that comes with the template. We don't need this model for our project, so we can delete it as well to keep the solution clean. Now let's start defining our domain model. First, inside the project, create a new folder and name it Entities. This folder will contain the core entities of our application. Inside the Entities folder, create a new class and call it User. This class represents a user in our system. For now, we'll keep it simple. The user entity will have two properties: a username, which will uniquely identify the user, and a password hash, where we'll store the hashed version of the user's password. It's important to note that we never store plain text passwords. Instead, we always store a hashed password for security reasons. Now let's add another important piece to our project. Create a new folder and name it DTO. This folder will contain the data transfer objects that we'll use to exchange data between the client and our API. Inside the DTO folder, create a new class and call it UserDTO. This class will be used to receive user data from the client, for example during registration or login. Using DTOs allows us to separate our API contracts from our internal entities, which is a very important best practice. It helps keep our application more secure, cleaner, and easier to maintain. Now, let's create our first controller. Inside the Controllers folder, right-click and add a new controller. Choose API Controller, empty, and click Add. We'll name this controller Auth Controller. This controller will be responsible for everything related to authentication and authorization, such as user registration, login, and later on, handling refresh tokens. Keeping all authentication logic inside a dedicated controller helps keep the application well organized and easy to maintain. Now, let's start writing some code inside our Auth controller. First, we'll add a new HTTP post endpoint and call it Register. This endpoint will be responsible for registering new users. The action will return an action result of user, which means our API will return the complete user object once the registration is successful. Inside the controller, we'll also add a password hasher. This will allow us to securely hash user passwords instead of storing them as plain text. For now, to keep things simple, we'll create a static user instance, something like a new user stored in memory. Once the user is created and the password is hashed, we'll simply return OK, sending back the user as the response. Now, let's test what we've built so far. First, we need to add a new NuGet package called Scalar. This package will give us a clean and modern UI to test our API endpoints similar to Swagger. Once the package is installed, we need to configure it inside the program.cs file. So open program.cs and add the required reference and configuration to enable Scalar in our application. After that, we can run the application and use Scalar to test our register endpoint and make sure everything is working correctly. When the application starts and we open the browser, we don't see anything yet, and that's completely normal. What we need to do first is make sure OpenAPI is enabled. OpenAPI generates a JSON document that describes all our endpoints, request models, and responses. This OpenAPI JSON file contains everything Scalar needs in order to display our API correctly. Now, since we're using the Scalar package instead of the default Swagger UI, we need to change the URL we're using in the browser and point it to Scalar's interface. Once we do that, Scalar will load the OpenAPI definition and display all our available endpoints. Now let's test our register endpoint. We'll add a username and a password, and then send an HTTP post request. As you can see, the request is successful, and we receive a 200 OK response. In the response body, you can also see that the password is hashed, which confirms that our password hashing logic is working correctly. This means our registration endpoint is now fully functional. Now let's add the login functionality. Inside the Auth controller, we'll create another HTTP post endpoint and call it login. This time, the action will return an action result of string, because for now, the result of a successful login will be a simple string response. Later on, this string will become our JWT access token. Inside the login method, the first thing we do is check whether the user exists. Since we're still using an in-memory user, we simply compare the provided username with the stored user. If the user does not exist, we return an unauthorized response. If the user exists, the next step is to verify the password. We do this using the password hasher's verify method, which compares the provided password with the stored password hash. If the password verification fails, we again return unauthorized. And if everything is valid, we return OK, confirming that the login was successful. Now let's test everything again. If we go back to the browser and refresh the Scalar interface, you'll notice that we now have a login endpoint available. This confirms that our new HTTP post method has been correctly added to the Auth controller. Let's open the login menu and provide the same username and password that we used during registration. We then send the post request. If everything is configured correctly, the API responds with a 200 OK status, which means the login was successful. This shows that our user existence check is working and that the password verification using the hasher is also functioning as expected. Now let's move on to generating our JSON Web Token. Inside the Auth controller, we're going to create a new method called createToken, which will take a user as a parameter. This method will be responsible for building and returning a JWT for an authenticated user. The first thing we need to do inside this method is define a list of claims. Claims are pieces of information about the user that will be embedded inside the token, such as the username and, later on, the user's roles. After defining the claims, we'll need to create a signing key for the token. This key is used to sign the JWT and ensure that it cannot be tampered with. But before we can do that, we need to import a NuGet package called Identity Model. This package provides useful helpers and constants that make working with claims and tokens much cleaner and more readable. Now, we need to add some configuration for our JSON Web Tokens. Open the App Settings JSON file. This is where we keep application configuration values that can change depending on the environment. Here, we're going to add a new section called Token. Now, let's prepare our application for persistence. First, create a new folder and call it Data. This folder will contain everything related to data access and database configuration. Inside the Data folder, add a new class and name it UserDBContext. This class will represent our Entity Framework Core DB context and will be responsible for interacting with the database and managing our user entities. But before we continue, we need to install Entity Framework Core. Open the NuGet Package Manager and install the Entity Framework Core package that matches our target framework. Entity Framework Core will allow us to work with our database using strongly typed C# classes instead of writing raw SQL. Once the package is installed, we'll be able to configure our UserDB context, add DB sets, and start persisting users properly instead of using in-memory data. Now let's finish setting up our database layer. Inside the UserDB context, we'll define a DB set of user. This DB set represents the users table in our database and allows us to query, add, update, and delete users using Entity Framework Core. With this in place, Entity Framework now knows that our application is working with user entities. Next, we need to install a couple of additional NuGet packages. First, install Entity Framework Core Tools. This package is required to work with migrations and database updates from the command line or from Visual Studio. After that, install the Entity Framework Core SQL Server package. This allows our application to use SQL Server as the database provider. Open the program CS file. This is where we configure all the services used by our application. Inside the Services Configuration section, we'll add our UserDB context and tell ASP.NET Core to use SQL Server as the database provider. This step connects our application to the database and allows us to inject the DB context anywhere we need it, such as in controllers or services. Open the App Settings JSON file again. Here, we're going to add a connection string that tells Entity Framework Core how to connect to our SQL Server database. We'll add a new section called Connection Strings, and inside it, define a connection string for our application database. Open the user class and add an ID property. This ID will act as the primary key for our users table in the database, and Entity Framework Core will use it to uniquely identify each user. Once the ID is added, we're ready to create our first database migration. Open the Package Manager console in Visual Studio. Make sure the correct project is selected as the default project, and then run the following command: add -migration initial. This command tells Entity Framework Core to scan our model, compare it with the database, and generate the initial migration needed to create the schema. Then run the following command: update -database. This command applies the migration to SQL Server and physically creates the database and tables based on our Entity Framework Core models. Once the command completes successfully, our database will be created and the users table will be available. At this point, our application is fully connected to a real database instead of using in-memory data. Here you can see that everything worked as expected. If we open our database in SQL Server, you'll notice that the users table has been successfully created. This table is generated directly from our user entity and the migration we applied using Entity Framework Core. Seeing the table in the database confirms that our DB context, connection string, and migrations are all configured correctly. Now, let's clean up our architecture and move the authentication logic into a dedicated service. First, create a new folder and call it Services. Inside the Services folder, create a new interface and name it Auth service. This interface will define the contract for all authentication-related operations, such as registering users, logging in, and later generating tokens. Next, in the same folder, create a new class called Auth service. This class will implement the Auth service interface and contain the actual authentication logic. Inside the Auth service interface, we'll add two methods. The first one is register async. This method will handle user registration and will be responsible for creating a new user and saving it to the database. The second method is login async. This method will handle user authentication and validate the user's credentials during login. Inside the Auth service class, we're going to inject two things through the constructor. The first one is the user DB context. This gives the service access to the database so we can create and retrieve users. The second one is the configuration. We'll use this to read settings from App Settings JSON, such as our JWT token configuration. Now let's implement the register async method inside our Auth service. This method takes a user DTO as input and returns a user, or null, if the registration fails. The first thing we do is check if a user with the same username already exists in the database. We use any async on the user's DSBET to perform this check asynchronously. If the username already exists, we immediately return null, which allows the controller to handle this case properly. If the username is available, we create a new user instance. Next, we generate a hashed password using the password hasher. This ensures that we never store plain text passwords in the database. Once the password is hashed, we add the new user to the user's DSET and save the changes asynchronously. Finally, we return the created user. This completes our registration logic using Entity Framework Core, password hashing, and proper async database access. Now let's implement the login async method inside our Auth service. This method takes a user DTO as input and returns a string, which will represent our JSON Web Token. First, we try to retrieve the user from the database using the provided username. We use first-or-default async to search for the user asynchronously. If no user is found, we immediately return null, which means the credentials are invalid. If the user exists, the next step is to verify the password. We use the password hasher and call verify hashed password, passing in the stored password hash and the password provided in the request. If the verification fails, we again return null to indicate an unauthorized login attempt. If both the user lookup and password verification succeed, we call create token, passing in the authenticated user. The generated token is then returned as the result of the login process. At this point, we have a complete login flow that securely validates user credentials and returns a JWT. Inside the list of claims, we'll add a new claim called Name Identifier. This claim is used to uniquely identify the user inside the token, and it typically contains the user's ID from the database. Now we need to register our authentication service in the application. Open the program CS file. Inside the service configuration section, we'll add a scoped service registration for our authentication service. We register iAuth service and map it to Auth service. Now let's test everything again. We'll start by registering a new user. In the register endpoint, let's use the username Alice and the password Alice123, and then send the request. As you can see, the request is successful, and the response contains an ID, a username, and a hashed password. This confirms that the user was created correctly and saved to the database. Now let's verify this on the database side. If we open the users table, you can see that a new record has been added with the username Alice. This means our registration flow is fully working end-to-end, from the API through the service layer all the way to the database. Now let's test the login functionality. Open the login endpoint in Scalar. We'll use the same credentials we just registered, the username Alice and the password Alice123. Now send the HTTP post request. As you can see, the request succeeds and the API returns a token as a string. This token is our JSON Web Token, generated after validating the user's credentials against the database. Now we need to configure JWT authentication in our application. Open the program CS file and start by adding authentication to the services collection. As soon as we type Add Authentication and reference JWT Bearer defaults, Visual Studio shows an error because the required package is not installed yet. From the suggestion list, choose Install Package Authentication.jwt Bearer. This package provides everything needed to validate and process JSON Web Tokens in ASP.NET Core. Now let's add our first protected endpoint. Inside the controller, we'll create a new HTTP GET endpoint. On top of this method, we add the authorized attribute. This attribute tells ASP.NET Core that this endpoint can only be accessed by authenticated users. Inside the method, we simply return an OK response with a message saying you are authenticated. Even though this endpoint is very simple, it's extremely important. It allows us to verify that our JWT authentication setup is working correctly. If a request is sent without a valid token, access will be denied. First, we try to call the endpoint without providing any token. When we send the request, the API responds with an unauthorized error. This is exactly what we want, because the endpoint is protected with the authorized attribute and unauthenticated users are not allowed to access it. Now let's test it again, but this time we include the JWT token we received from the login endpoint. We add the token to the request using the authorization header, with the value bearer followed by the token. Now when we send the request, the response is successful, and we get a 200 OK status. The message, "You are authenticated," confirms that the token was validated correctly and that the user is authorized to access the endpoint.